So a sample of digital pathology, let's say, for example, a workflow would be, where you look at the whole imaging, whole WSIs, right? And then you look at the WSIs and you do some sort of image analysis on this, on tumor detection or subtyping or grading. And then you do, if there's a prediction and you're doing personalized therapy, then you do that. You do some of the things that are mentioned there. And eventually advancing the histopathology, you do that. The key point that I want to mention is the application that you use on the first one is image analysis. The second one is an image analysis and a predictive power. The third one is image analysis, predictive power, and then there's some sort of spatial temporal relationship with respect to biological interactions. Okay, what am I driving at? What I'm driving at is AI is not monolithic. So just because you're using AI doesn't mean everything is in one big box of AI. It comes with different kinds of analysis, different kinds of things that happen. So first thing is we need to understand is that, or at least I'm trying to lay out that conjecture. So why and I'll take a couple of slides and just try to lay a very big topic in 2 slides. Okay, so the first thing is we all know statistical methods. A lot of physicians that I work and I did some research with them, they understand statistics very well. Okay, so they understand, they know how to compute the hypothesis testing, the p-values. Typically, when you do research with physicians, what they do is you get all the results. They finally get a statistician and compute the p-values and all the stuff, and then that's how you get the published and get a new co-author, and then that's how you publish the paper, right? So this part they very well understand. Okay, so what's happening here is it's a lot of statistical. There's a blurry line between statistical and classical ML and classical statistics learning. I don't want to go into that debate, but I just want to draw some sort of boundary line, not boundary line, some sort of evolution there. The primary focus is inference and understanding when you do statistical approach. That means you have some values, you're trying to understand a variable, you're trying to get how the distribution is across and how you place that, and then you can explain it. Okay, so it doesn't need a lot of data. So you can just do small sets. That's why it's been working well for over a period of time. Except is it our data set or somebody else's data set? That's different, but it's been working well, right? So on the other hand, the approach for machine learning is predictive power. So what you're looking at is you're learning from the data. So you're not going into statistical theory and then coming back and then trying to explain things, but you're saying that I'll take the data, I'll learn from the data, I'll learn the patterns, I'll learn other things, and then I'll learn. So what does that give you? That gives you predictive power. Okay, but there's fewer assumptions on the model. When you do statistical things, the population is like a normal distribution or something else, but you don't need to make those assumptions anymore because you know the population. They are coming to the hospitals. You know what the population is. You don't need to make any assumptions about them. You just get the data and then see what is happening there. What do you lose? You kind of lose some sort of explanation there. In some cases there is. Okay, but it thrives on data sets. Okay, and that's a big shift that is happening. So I'm looking at the clock there. So let me quickly do, and then move into a whole bunch of thing called deep learning, right? Where what's happening is what you're doing is you kind of even taking some of the assumptions or some of the things out of there in machine learning, where you need to say these are the features I have, these are some of the things that I have, and trying to learn from the data, but you're trying to learn some sort of representations in the data. So what is happening deep inside the representations? So can I learn the representations of data, not the patterns, not the things, but how the representation, and then the representations will give me some sort of inferencing. See, we come back to inferencing, but coming back to inferencing in a different way. Okay, so if I understand my nose, ear, eye, then I know it's a face. I'm understanding the representation of face. Okay, so that is what is happening in the deep learning. So AI isn't monolithic. The first thing that I want to say is. Second thing is this is the transformation. So each one has its own applications. So when you everything gets a part of your workflow. Sometimes it's classic statistical methods. Sometimes it's explainable machine learning predictions. Sometimes it is deep learning that is coming your way. Okay, so we need to understand that. So let me quickly move on. So what deep learning did fundamentally is because vision is pattern-based, vision is representation, language, speech and language. So tremendous progress on vision, speech and language, because it's understanding the inherent representations of those and trying to put together. There's a whole bunch of things that happen there on top of that, but I'm just taking note. So what this drove is, in a combination of this, then you go to the applications in healthcare with all these things, whether it's virtual assistants, diagnostic tools, imaging, or simple, like I was saying, simple prediction of your LPA based on some sort of distribution and some sort of, obviously there's a method as well, right? So, okay, let me quickly move on. So fundamentally, when an application comes in front of you as a clinician, you need to understand you have some sort of evaluation. If it is a statistical method, there's one way of looking at it. If it is if it is a machine learning, there's another way of looking at it. I'm trying to rush here because of the minute. So there's a deep learning, then it does complex tasks, but the way you evaluate is completely different. So this is what you need to understand when you do this. So essentially, the key thing is it achieving my goals, and can I can I trust it based on my metrics? So do not treat AI that comes your way in one singular way. Each has its own metrics, each has its own way of expectations and what it can do.